Especially my goal is that you all get poised into engineering and sciences, because that's what I do. And I would love to see you enrolling at UH and actually coming to work in my lab as an undergrad. That would be a great thing. Even if it doesn't happen, hopefully today's visit will stay in your memory because we'll have a lot of fun. I'll show you some things about the batteries that you probably never thought you know, but you do know them, you just never thought about batteries in the way that I'm going to tell you. So we will not talk about difficult things, no chemistry really, horrified equations and so on. We'll talk about something that you can do at home. And I will, when we go to my lab, I will divide you in 4 groups, 5 students each. And then you will perform different experiments, and who is the best, Ms. Castillo and, Santi will decide, they will be the judge. Who performs the best, the group will win the present. So keep an eye on competition. The second thing I want to tell you is that, as you know, most of the stuff today gets complicated. You need education to succeed in your life. Not because this is some fancy thing to have a title, but because pretty much anything you do now requires certain level of your understanding of the subject. Simple thing is, if you're going to be a farmer, you have to know these things very well. You have to read the books. Ideally, you have to graduate some agricultural program. And then you will be a very, very good farmer and you will make a lot of money. You will provide for your family, for your kids. If you're going to be an engineer, you will be probably employed someplace, but the good engineers keep the job, and the engineers don't. Okay? Scientists as well. Doctors, again, good doctors, everybody likes them. Bad doctors get sued, and so on and so on. So it's important you understand that the success in your life is pretty much related how much effort you invest in yourself through the education. Or you have other options, rich or marry the rich guy or girl, and then all your problems are solved. Now, I was never pretty, so I had to work hard to provide for myself and my family. So who is pretty can take the other option. I don't know, American Idol, etc. Odds are very little. Very few percent ever get a chance to even compete in American Idol. So this is a reality show that sells you a fog about life. It's easy, you know. Life is about the work, not about taking odds, okay? Hard work, that equals success. Everything else is just reality show that makes millions but has nothing to do with reality, okay? I'll tell you this as somebody who has gone a little bit further in his life. Now, play lottery, that's okay, you might win. Odds are really, really small, but you know, spend a few bucks every week, it's not bad, it's for fun. But don't play and gamble with your own life. That's what is not good, okay? So, enjoy your breakfast. I just give you this introductory note, and I'll tell you a little bit about batteries through the breakfast. And then we're gonna go and just take a couple pictures outside of the building and so on. And then after that, we will go into lab. Groups will be formed. We'll do some experiments. After experiments, the pizza lunch will come, and we'll talk about what you guys liked about what experiment. Somebody will probably succeed in experiment, somebody will not. So it stays for you to try when you go back in your chemistry labs, the same thing, and so on. Okay, so I really want you to wish you a very warm welcome and enjoy your time today in UH. Hopefully you come back for some more experience. And I need to kind of, you know, memorize your name, so it would be good if you start from this side and everybody tells me who he is, where he lives, and so on. Is that okay? David, how about you? Oh, by the way, didn't tell you, my name is Brankovic. For you, you can call me Dr. Brankovic or Stan, it doesn't matter, okay? People mistake me for some actor which acts in some violent movies, but don't get this impression, I'm not violent at all. Okay? So David, where do you live? Which part? Inside. Is there any name of the area where you live? Did you have a breakfast before? Somehow your voice is so weak, I don't hear it. Okay, how about yours? Similar. Okay, how about you, was it?
I don't know, Wood Forest.
Wood Forest?
Don't wait.
Okay, so the Christopher,
North Shore.
you play basketball?
Used to.
Used to? Why you don't play now?
Because I don't have any time to.
Oh, so you're scientist then? Or girl?
Yes.
What? How about you, Master?
Wood Forest.
Wood Forest. Alfredo?
Underwood.
Okay, and what's your name? Try? Tree, sorry.
Yeah, I live at New Forest, near the Bellway.
Good. And Alexander?
Riviera East.
What?
Riviera East.
Riviera East. And your name is? Can I see the tag? What is this? Betsy. Oh, sorry. I heard Betsy. So, where you live? Wood Forest. How about you?
Wood Forest.
What's your name?
Ivan.
Ivan?
Yeah, I didn't get a name.
Didn't get a name tag? Jimmy? You're gonna get minus 3 points today. Okay,
I know
Clarita?
the name, I guess.
North Shore.
North Shore. And Erica?
Wood Forest.
Wood Forest? Vanessa?
North Shore.
North Shore. Okay, so you guys are pretty much focused around your school, am I right? Most of you do not travel that far. Good. Lester?
New Forest.
Forest, okay. Jasmine?
Yes, ma'am.
Oh, yeah, sorry.
I don't know.
Where do you live? In the school? Okay, that's fine. Alexander, where do you live?
Wood Forest.
Wood Forest, okay. Joshua?
Wood Forest.
Christopher?
Similar area.
Okay. Good, so when I go to pick up my garage door, I'll stop to your school. There's a place where I have to go and get my garage door, which is right above where your school is. So maybe I'll pay you a visit one day. Carmen, where do you live?
I live in Riviera East.
Good. So, let me give you just an idea of why we're all doing this. The most important thing is we want you to succeed in your life. And as I said, this is through education. Unfortunately, I didn't add your name, but I will add it
I was the
on.
last minute.
I will add it on the web. So the idea is that we create an outreach program that will be alive. That every year we go through this exercise and experience to different students. Some of you can come again, it doesn't matter. And you learn some things that you typically wouldn't learn in your regular curriculum of chemistry or physics or so on. The other interest is, besides you, is to voice Sarah to come back and do PhD with me, which we want. But she's laughing, looks like she's very interested. Well, but the thing is, we want to create something that will serve everybody for the better. Okay? And that's what we call this high school outreach program between your school and University of Houston, where I will be leading this from my side, and Ms. Sarah Castillo will be leading this from your side. Okay. Now, everything we're going to talk about today, I'll create educational movies, some materials, presentation like this one, and you will be able to go on www.egr.uh.edu/electrochemical nanofabrication group, is this ECNFG outreach, and have a look. There will be your pictures, there will be some interesting movies about your experiments, some text, nothing heavy in math, nothing heavy in chemistry. It's more like a regular story where you can show your parents or your older brother or younger sister what have you done or what did you do today. Okay? This is the sign of my research group. We call this electrochemical nanofabrication and nanomaterial synthesis group. Very complicated name. Not going to tell you what it means because it doesn't matter at this point. Okay. Now, as I said, the visit schedule. I hope to finish with this presentation and your snack by 10. Then we'll walk around the building, take some pictures, and show you how the amphitheater looks like, how the labs look like. Maybe, I don't know, my office hasn't been cleaned in 6 months, so maybe I'll pass by my office so you can see how the professor's office looks like. But if something jumps on you from the corner, don't get afraid. Then we'll perform some experiments and demonstrate a battery principle. So you can go home, and if it happens that you don't have a, for example, a AAA or AA battery to run something, that you can fix your own with the things that you have at home. And then we're going to come back in this classroom and talk about what we learned today and have a lunch. And then you'll come back probably sometime between lunch. Okay. So when you say batteries, you don't even know how much they mean for modern society. Pretty much. Everything here has some kind of power provided by battery. For example, what is this? What is this?
It looks like a
Watch.
Yeah.
It's electrical watch. Every single watch you have, most of you, unless you have some fancy Swiss watch which is self-winding. It's powered by battery, right? What would you do if there's no battery? You will be doing this thing every 15 minutes, right? And eventually it will break. The fastest car in the world, period, is Tesla. Powered by batteries, not by gas engine. Okay? The record is from 0 to 60 miles in less than 2.3 seconds. That's Tesla. Then if you go to the beach, you want to listen to some music, what do you need? Besides that, a lot of D batteries, am I right? Okay? If you want to record your birthday, or your boyfriend, or girlfriend, or whatever, like Dietrich is doing now, you need also, besides camera, you need a battery, right? Who fixes the stuff at home probably have seen these fancy tools that are self-powered by batteries. Or most of you, I guess, have laptops to download music, play movies, am I right? And they need also batteries unless you're going to sit next to the plug, right? But if you're going to sit on the beach and watch the movie, you need a battery, right? Then MP3s. More important, I have a 5-year-old son. I didn't realize how much money it cost me to buy toys. But guess what? Even more money cost me to buy batteries for the toys. Every single toy today has some kind of action, sound. You need batteries for them, right? Even satellites use batteries because the power is provided from the sun, but when the satellite goes back behind the Earth, and the sun is actually behind the Earth in a shadow, then it uses batteries to operate. Then cell phones. Ooh, everybody here is probably cell phone freak, right? How many of you have a cell phone? Oh man, that's outstanding. Okay, cameras. Now, does anybody know what is this?
Whoa, what is?
Hey?
Whoa,
What is this? Have you ever seen this before? This is basically a tiny battery with a tiny device called pacemaker. And some people are born with problems with their heart muscle stimulus. And they're weak, they don't have any energy. And what happens is that you implant this behind the skin with a couple electrodes in the heart muscle, which provides the electric stimulus to the heart muscle, and these people actually can live a normal life. And once in 15 years, what you do is just replace this battery. And these people actually have no difference of doing anything, like very healthy ones because thanks to the tiny battery that provides electrical stimulus to the heart muscle. So we all agree that batteries are something phenomenal, am I right? There are many definitions about battery. I'll give you the simplest one. It's a device that stores chemical energy, which could be conveniently converted to electricity or electrical energy at any given moment. Now, you're familiar with this shape of battery, right? But there's three elementary parts that you cannot forget the battery has. It has a positive electrode, like the one in the center. This is that tiny nipple, right? Always positive. Then it has negative. Now, in your case, remember, positive is copper, negative is zinc. So positive is the copper that goes to connect to this red lead. Negative is zinc that connects to this black lead, okay? Now, how are you going to do this? Simply, you stick one zinc lead here, and before you do anything, what you want to do is clean your electrodes with the sandpaper, okay? Basically, you just remove some oxide that exists, okay?
Okay, so what do you have? Sandpaper.
Okay? And then you stick a copper in a potato. And you stick a zinc. But you want to also make sure they're not too far away from each other. Not too far apart, okay? And then you do the same with this potato and this. And then you use these alligators or these leads to connect zinc from here to copper to here, zinc from here to copper to here, right? What is left is zinc from here and copper from here. Zinc is negative, goes to black one, and copper is positive, goes to red one, okay? So clean the electrodes, stick them up, and then connect them in between, like a serial connection batteries, and then we'll see if you're gonna play the music or not. Call me if you need my help, okay? Go into the circuit. Let's say we have some resistor or light bulb, whatever. Let's say we have sound speaker. Okay? Now what is here is a copper, right? Let's assume this is all, for example, part of the lemon. Okay? This is lemonic acid, or let's say acetic acid. Okay? This is electrolyte. Okay. So what happens here, copper is the bulk, which are copper ions. So what happens, these electrons come here, and copper 2 plus, which is a solvated form, gets 2 electrons and goes to copper bulk, which basically means that this copper 2 plus here comes and deposits on the copper electron. Okay? So that's what's going on. So when this is going on, you generate electricity. This sound speaker works, right? So now what I do, I say stop the circuit and I connect. I reverse this back. It's okay. So I'm using some source to provide the power here, say battery, whatever. Now I'm forcing zinc that has been dissolved, okay, to come back here and deposit. Okay, so I'm recharging it. Okay? And I'm also forcing the copper that has been in the that has been deposited on the copper electrode to go back to the solution. So I'm recovering the situation that has been before. Okay? And when I stop this process, okay, and I can also connect a light bulb now and rerun it again. Because obviously you guys understand, if I keep dissolving the zinc and depositing copper at one point, it will stop. Alright? Because the whole copper from here will be on the electrode and the whole zinc from here will be dissolved. So eventually the battery will not work forever. Right? Now, the ones that we've done in our lab are not exactly Daniel cell. Okay? I just want to explain that. The Daniel cell is what I'm talking about here. But exactly what happens in a lemon is that instead of having copper depositing here, what happens is actually, in most of the sense, hydrogen ion, which comes from the water, or electrolytes, come, get 2 electrons, and convert to the hydrogen gas. And you see the bubbles on copper electrode, which are actually hydrogen gas. That's what happens in the real lemon. But the Daniel cell, because it has the separator here, which is the membrane, you know, we put the copper ions, they don't mix with the zinc and so on. I don't want to go into these details. I'll write a nice story on the web page. You can read it, and then learn it, and then Ms. Castillo can test you on that if she wants. I don't know.
Next week.
But the thing is, I don't want to give you too many informations for the first visit, because I want to just give you a story that flows. Which is important more for you is to get a glimpse of the chemical energy conversion to electricity, and the theory and chemistry. You have, you know, enough time in a class to go through that. Am I right? The demonstration of the principle is important, and you'll learn a little bit more about the details and so on. That's the point. So I'll write the story in the web. You'll see your teachers doing the experiment. We'll have a movie about how you do your experiments and a little bit about batteries and so on. And so you will have all your stuff there. And actually, let me ask you something. Is your school having a web page for such things? So basically, you can relink your chemistry to something that comes from the nature. It's a natural source of energy. Chemical energy is stored in everything. Okay? The way you extract it is engineering. So making battery, connecting the wires, sticking the zinc and copper into lemon. That's part of engineering you have to do. Okay? If you have a pot with some kind of beautiful flower and you water it, stick a copper and zinc in that pot, and you'll see it'll give you electricity. Pretty much any two dissimilar metals like aluminum foil or your fork stuck in vinegar will give you some kind of electricity. Electricity is everywhere. You just need to learn how to extract it from the chemical energy stored in nature. That's all. So today you learned some examples, but there are many more. And you know, I don't encourage you to destroy whole kitchen of your mom, but you can try and play, you know. Sometimes some fruits work better than the other. They're fresh, they're better. Actually, kiwi works very well. It's probably the best. So, you know, this electrolyte that you have in the fruit plays a very important role. And you will see it. Rotten apple is not as good as a fresh one. Strawberries are very good as well. And so on and so on and so on. So, cleaning agents that you use for cleaning bathroom are very good. Because this is diluted HCl, hydrochloric acid. And they provide a very good electrolyte. So, you know, instead of wasting money sometimes, or waiting for tomorrow for the stores to open, sometimes you can fix your own batteries. That's the message to take home. Because you're chemists already. You don't know that, but you're already chemists.
Hi, camera. My seniors, I think most of them are.